stoichiometry involving volume. Some prerequisites you should have are mass calculations, modal calculations, and balancing equations, and previous units. All right, so as we already know, periodic tables, each element has a different number of molar mass. We can divide by this or times by this to find how many moles are in a equation, and use that moles to times by a new element's molar mass to find it. Well, when we're using liters, it's a universal scientific standard that every mole has 22.4 liters in it. So for every mole, regardless of the molar mass, it's going to take up 22.4 liters of space. And so unlike by molar mass, where we divide in times by all these different numbers, I think it's a lot easier because you only times and divide by 22.4. You'll have two types of equations. Usually with volume, you either have mass or represented particles, and you convert it to volume, or you have volume which you convert to something else. And both of these basically have a given and an end result, and then you convert it both to moles, and you use the ratio of how many moles of the X or the given element you have and try to convert it to how many moles of the Y you have, and then just times it by whatever you're trying to find your end result. All right, let's look at an example. Okay, so for an example, how many liters of ammonia will be produced from 10.0 grams of hydrogen? So I'm just going to write Pound's equation, 3H2 plus N2 equals 2NH3. And then so we're going to start with a given 10 grams of hydrogen. Like always start with the given. We're going to divide it by molar mass, because this one's going to be moles, or not moles, sorry, molar. It's going to be mass to volume, right? We're given grams. We got to go to liters. So first, we're going to try to find moles, so we're going to divide by molar mass. We're going to divide by molar mass of H2. Then we're going to use the mole ratio. We got 3 moles of H2, 2 moles of NH3. And you should already know this by now, but you always divide by whatever element you put over here, and then times by whatever the element that you're wanting to go in. That way it always cancels out from like diagonally with, mole H2, mole H2, that'll cancel out. Same with H2, H2. That way you get the right, labels. Anyway, and then at the very end, once you find how many moles of NH3 you're going to have with 10 grams of hydrogen, you're going to times by 22.4 liters, meaning for every mole there's going to be 22.4. So for every moles times by 22.4, that'll be an end result of 73.9 liters ammonia. All right, let's go for the first problem. Okay, determine the volume of hydrogen gas produced at standard temperature and pressure when a 2-gram piece of aluminum completely reacts. All right, so try to work this one out on your own, and I'll go through it now. All right, so first we're gonna start off by balancing the equation, writing it out, using, understanding which compounds and how many moles is very important. So we're gonna start off with our given 2 grams of aluminum, and we gotta identify what we're trying to find. We're trying to find hydrogen gas, so we're trying to find this. So given this, trying to find that. As you can see, it's a 2 mole to 3 mole. But however, though, since we're in grams, we're given in grams, divide by molar mass. That's gonna give us how many moles we have in the equation. Instead of divide by 2 times by 3, it's gonna give us how many moles of H2 we have. Once again, we're lining up diagonally, the same labels as always. And then once we find how many moles of H2 we have, times by 22.4 liters, just the universal. See, I feel like this is really easy compared to molar mass, because it's just a set unit. If you type that in the calculator correctly, you'll get 2.49 liters of H2. All right, let's move on to problem number 2. Problem number 2, what is the mass of calcium oxide? What is the mass of calcium oxide is required to react completely with 1.4 times 10 to the third liters of sulfur dioxide? All right, first step, like always, writing out the equation, balancing it. If you did that correctly, it should look like this. And we start off with our given. It's 1.4 times 10 to the third power liters of sulfur dioxide. And then right now it's in liters. And so it's asking for mass, so we're converting from liters to mass. So we need to divide by 22.4 liters. Divide by 22.4 liters over 1 mole SO2. Now we're going to use the ratio. There is 2 moles of SO2 to find the calcium at the 2. So it'll be 2 to 2. As you can see, 2 to 2. And you can always simplify these to 1 to 1. And then once you find how many moles of CaCO you have, times it by molar mass, that's going to get the mass. That's how we went from liters to mass. That's the answer. Alright, for problem number 3, see if you can solve this one on your own. Take a minute to pause the video. Alright, I'll go through it now. So for the reaction of 3Na, 2CO3 plus 2AlCl3 equals Al2 plus 6 NaCl, what volume of 1.2 moles Na2CO3, as in if 1.2 moles of this, so 1.2 moles of our reactant, is needed to react with 5.0 liters of 0.3 moles AlCl3, what is the volume of 1.2? Alright, so we're going to start off this equation by taking our given 5 liters, and we're going to be turning it into how many liters of 1.2. So this is a liter-to-liter problem. And what we're going to use is, first we're going to figure out from how many liters we're going to turn it into moles from how many moles of this. And once we have moles, we're going to use a 2 to 3 ratio, as we have in the problem. At the very last one, we're going to use, once again, the rate they gave us, 1.2 moles for 1 liter. So this one technically doesn't use the standard 22.4 liter rate, as they kind of make up their own numbers with the 1.2 moles for 1 liter. Or sorry, no, 5 liters have 0.3. And so this is just an extra step on it, and you probably won't see these equations most likely, but that's how, using the 0.3, you can convert it, and then using the 1.2, and the end result will be 1.875 liters Na2CO3. So this is a really hard problem. This is, they're supposed to be the hardest one. You probably won't see most problems like this, but it's good to know how to do it. All right.